Good morning, students. So, in the last lecture, we have seen the definitions in the compass traversing, that is, what is a true meridian, magnetic meridian, arbitrary meridian, grid meridian. So, today we'll see the fifth definitions. Okay, so designation designation of magnetic bearing. So this is very important. Designation of magnetic bearing. So how we will measure the angles in the compass traversing. Okay, so generally we have two designations. Okay, the first one is called as a whole circle bearing. Whole circle bearing, it is WCB. And the second one we have quadrilateral bearing, it's called as a QB. So first we'll learn what is a whole circle bearing. Whole circle bearing, simple. Okay, the magnetic bearing. Okay, the magnetic bearing of a line measured clockwise from the north pole towards the line is known as the whole circle bearing of that line. Okay, so just I will draw here. See, suppose this is a north line which shows the magnetic needle, okay, so we know this is east, west and south. Okay, now as per the definition, what is the definition? The magnetic bearing of a line measured, important, measured clockwise from which from the north pole, towards the line, okay, is known as the whole circle bearing of that line, simple. Now this is north, okay, which shows the magnetic needle. Okay, so we have magnetic bearing, so we know what is the magnetic bearing. Okay, the angle between magnetic meridian and a line is known as magnetic bearing, and we know the magnetic meridian is nothing but the magnetic needle which is suspended freely and balanced properly, unaffected by the magnetic substances. It indicates a direction. This direction is known as magnetic meridian. Okay, and the angle between magnetic meridian and a line is called as a magnetic bearing. So this north shows the magnetic needle. Okay, direction shows the magnetic needle shows. So okay, so what is the magnetic bearing of a line measured from the clockwise from the north pole towards the line? That means suppose we have quadrants, first, second, third, fourth. Any point will take, suppose this is origin, Suppose we have a line, this line AB. Okay, so what is the magnetic bearing? That is, what is the whole circle bearing? Whole circle bearing of a line AB. What is the whole circle bearing of a line AB? So what will be the, so for whole circle bearing is nothing but the magnetic bearing of a line measure clockwise from the north towards the line, that is called as a whole circle bearing. So the whole circle bearing of AB equals to theta 1, equals to theta 1. Simple. Now suppose in the second we have a point, line AC. We have AC. Here also the magnetic bearing of a line measured clockwise from the north pole towards the line. Okay, that is what the whole circle bearing of a line AC. So what is the whole circle bearing of AC? Equals to theta 2. Simple. Now next one, suppose we will take in this coordinate, suppose AD. So the bearing, magnetic bearing of this line measure from the north towards the line clockwise direction. So that is what the whole circle bearing of AD. That means what is the here whole circle bearing of AD equals to theta 3. Now in the last one, suppose in this quadrant also, if you have point E point, so the magnetic bearing of a line AE measure from the north towards the line, okay, that is, suppose this is theta 4, the angle is theta 4. So whole circle bearing of AE is theta 4. That is called as a whole circle bearing. That is called as a whole circle bearing. Simple. Okay, you understood what is a whole circle bearing? So it is always measuring from the north pole towards the line in the clockwise direction. That is called as a whole circle bearing. That means if I say what is a whole circle bearing for a line AD, whole circle bearing of a line AD, that is nothing but theta 3, which is measured from the north towards the line in a clockwise direction. That is what the whole circle bearing. Now we will see the quadrilateral bearing. Second one, quadrilateral bearing. Okay, now so the definition changes. Now what is the definition? Just to see, the magnetic bearing, the magnetic bearing of a line measured clockwise or counterclockwise, or we can say the anti-clockwise. Anti-clockwise from the north pole, or south pole, north pole or south pole, whichever is nearer to the line, whichever is nearer the line, whichever is nearer the line towards the east or west is known as the quadrantal bearing of the line. Okay, of the line. So we'll see, we'll draw a sketch. Same, we have north, we have south, east, west. Okay, so as per these definitions we have 4 quadrants. Okay, so we should have the system consists of 4 quadrants. Okay, so that means what are the quadrants? So we have northeast, southeast, southwest and northwest. Correct? Is we have 4 quadrants. Sorry, we have 4 quadrants. Okay. Now, as per the definition, magnetic bearing of a line measure clockwise, or measure clockwise or anti-clockwise from the north or south pole. That means like this, south pole towards the east or west, that is what the quadrantal bearing. So how we'll see? Okay, same line will take. Suppose this is A, we have B, C, D, E. Correct? So the quadrantal bearing of AB equals to, now as per the definition, whichever is nearer angle. Now for AB, north is nearer than the south, so we will measure the angle bearing from the north towards the east. That means north towards the east. Suppose this is theta 1, so theta 1 towards the east, north, theta 1 towards the east. So similarly, quadrantal bearing of line AC. Now this line AC is near to the south, so we'll measure from the south. Now towards the east we'll measure like this. Suppose this is theta, so south, theta 2 towards the east, so like this. Quadrantal bearing of AD, now this AD line is nearer to the south. Okay, so we measure from the south, but it is now the clockwise direction towards the west. So the south theta now, so this is what the theta 3 towards the west. Quadrantal bearing of A equals to, now this line A is nearer to the north, so we measure from the north in a anti-clockwise direction towards the west, and this is bearing theta 4. So north theta 4 towards the west. Okay, so these are called as a quadrantal bearing. Okay, and the quadrantal bearings are obtained by the surveyor compass. Okay, by the surveyor compass. So this is about the magnetic bearing, whole circle bearing and the quadrilateral bearing. Whole circle bearing is always measured from the north in a clockwise direction towards the line. That means the whole circle bearing, the angle will be from 0 to, yes, what is the here, the angle may be here 0 to 360 degree. Okay, but in quadrantal bearing angle will be 0 to 90 degree, because we have 4th quadrants. Here there is no quadrants, always measuring from the north towards the line. Okay, simple. Okay, now next we'll see the reduced bearing. Now next okay, so we'll stop here. Next we'll see the reduced bearing.